Howdy, everybody in YouTube land. What we have in front of us today is a Wavetek function generator model 288. So I just recently went to the Stone Mountain Hamfest, and this guy, what attracted me to this guy is even though I had just fixed that fluke frequency generator, it doesn't do sweeping. So I can't do like an IF alignment sweep marker type related activity. However, this one does. And I remember seeing these in the past. I'm like, these things are kind of nice. So for a whopping $25, I couldn't pass it up. So this is a nice little signal generator. Now, I don't know what frequency it goes up to or anything like that. I'm hoping this can do like FM, IF alignments with S curves and stuff like that. We'll see. But it was only 25 bucks, and these things are worth far more than $25. So I have an itching suspicion something is wrong with it. Now, it looks like something was on the top at one point that was really, really heavy. So getting that off is going to be a little bit of gymnastics. So, okay, it's already plugged in. Let's see what happens when I turn it on. Power's on. Looks like we get this calibration required error, so there's probably already an issue. But you know what? The main electronics, as far as the microcontroller, is working because we have a display. So let's see. I don't know. Amplitude 5 volts peak to peak. Frequency 1 kilohertz. I guess it should be putting out a 1 kilohertz signal. There's our sweep. See what we get. Yeah, that's a problem. That explains why this thing was $25. So we are slammed to rail. Let's see what it does with all the other functions here. So triangles, square. Well, we kind of get something on square, but not really. DC, we got nothing. And AC, we have that. So what happens if we use sweep? Nothing. So yeah, it's not working. Let's see. Frequency. This is the knob works. So let's do 400 hertz. Nothing. All right. So does this go up to 1 megahertz? No. Let's see. 10000. 10 kilohertz. Well, it's kind of working, sort of. 1000000. 100 kilohertz. Yeah, I mean, let's see. Is the frequency correct? I don't know. It's kind of hard to tell because my trigger level isn't down there. So let's adjust the trigger level real quick. Trigger level minus 14. Yeah, I mean, yeah, the frequency synthesizer is working fine, but we've definitely got issues in that department. Let's see. 1000000. Enter. 10 megahertz. Yeah, that's working. So 1000000. Enter 100 kilohertz. 1 megahertz. Yeah, the synthesizer is working. 1 kilohertz. You can hear relay click inside when you go to a different frequency band, and that doesn't work at all. So we've got problems with frequency bands not working, and we got problems with it slammed to rail and distortion. That kind of screams to me that we have power supply problems, but I don't know. We're going to pull this top off and see what we got going on. So I'm getting ready to try to pop this lid off here. Warranty 1993. Serial number begins with 91. September 24th, 91. So it puts it in that era of, every time I turn around, it's capacitors. So I guarantee I got the same exact problem going on in here. Yeah, getting this lid off is proving to be a bit of a challenge because of how bent it is here. It's not coming off. I don't know how we're going to get that off yet. This was not a fun thing to get apart because holy crap. Had to take the faceplate off, get all the nuts off so the faceplate will come off. Just to reveal that there's hidden screws under these labels. And this thing was so bent, there was no way it was going to slide out anyways. And this thing looks like it's missing some screws. The side covers came off, so these are just the card slots. It looks like it's organized into multiple cards. So, alright, well, I need to get in here. Yeah, see, that is not going to want to come out because of how bent that is. See what I mean? It's just, we got to, in order for this lid to ever go back on, even this one, we're going to have to flatten all of this stuff out. This thing's got to come all the way apart. Yeah, I guarantee we have hidden screws under there as well. Let's see. Yeah, we do. So that's going to have to come off too. Fun times, but it is what it is. So getting this apart was absolute nightmare fuel. However, the good news is we actually have the service manual here. And the good thing about the service manual is the output section is kind of designed like a Class AB audio power output. We could be missing rail voltages. We got positive and negative 22 volt rails. And if we look in the power supply section, we have them back here. So just as a quick aside, real quick, with an extra side of quick, real quick, and quick, I'm going to measure the rail voltages and double check to make sure that they're properly present. So positive, it's there. Negative, it's there. All right, so we got rail voltages. So what we're going to do is we already know that we're getting the right frequency, so that rules out the synthesizer board and all of that stuff. We're just getting clamped hard over output. It's distorted. And it would make sense if the issue is in here. So what we're going to do is we're going to probe test point 2, which I think is going, yeah, it's going into this R2R ladder circuit, which comes out to the power amplifier. I don't see a power or a test point here, but I do see it there. So I'll tell you what we can do. We can measure test point 2, and if we look, this is the output board. We got 8, 9, 10, 4, and 5. 2. Question is, can we get to that one? Alright, well, let me ground this probe. And we're going to go ahead and shove that probe in here. Well, that looks good. It absolutely does. Let's get the trigger level moved up. Would you look at that? That looks amazing. We are at 1 kilohertz. So if we go to frequency, let's see, 10 kilohertz, enter. Man, it's really loud now. But we have it. And it's clean. It's very, very clean. Okay, so we know our fault is in the power amplifier stage. So we can shut you off. God, that's loud. Okay, so we have a problem in the power amplifier stage. And you know what? This thing is already hot. So my guess is the audio power amp, I call it audio power amp, Class AB power amp is in that section because I see Q18, Q20, and if I look here, yeah, Q18, Q20, so this circuit is at fault. So that means we got to take the output module out and start testing these transistors and look for shorts, things like that, because there's something went wrong in here. Now, I suppose the good news is I'm not seeing any extreme evidence of capacitor leakage anywhere. Like, I don't see any spilling on the board or anything like that. So it seems like they use decent capacitors in this thing. Also, it appears to have a battery here, and it's a Duracell DL2430. It's original. I don't have those, but it's dead. I'm going to see if I can't fit a CR2032 in there, and if I can't, I'll replace the socket and put one in there, because that 2430 is just not common. So we'll deal with that later. That's a separate issue altogether. First, we got to figure out what we got going on in here, and it looks like this metal piece comes out with it. And one thing I noticed is I like how these TO5 transistors have these weird little metal socks on them. That's kind of strange. So I got this board apart, and doing some quick dry checks to the power output stage here, I do not see any shorts. Now, I didn't go through each and every single resistor to look for any opens, but all of this is related to the power output stage, and none of that is shorted, and there's no obvious leakage. Now, I haven't pulled the transistors out and checked them out of circuit, but I don't want to keep chasing red herrings. The reason why I say that is because I'm looking at this schematic a little closer, and we have a voltage offset input right here, which comes from another board. So, I'm thinking here that if this is wildly off, like if this is extremely negative, it's going to change the input feedback on this differential amp, and it's going to drag the output negative, like it's doing. So I wonder if this is an issue. I got to chase this back and figure out what drives that. Now, the generator should run with the output board removed, for the most part. Now, if we chase back the V offset, it goes to this Class AB amplifier setup here, which is fairly common with anything like headphones or something like that. But so what we need to do is, again, we just continue working backwards here, because we have our 4051 MUX. I'm not quite certain how this circuit works, but I'm assuming this all goes to different features and stuff like that for the synthesizer board and all that. I don't know if the rest of this is working or not, but what I do know is we can check this to see if it's like extremely negative, and if it is, we can chase all the way back and find out why, because it's using a negative feedback here. So we need to look on this side of this unity gain op amp and see and make sure that this is adjusting when you adjust the voltage offset on the front panel, and that it's not extremely negative. Because if we're missing a voltage here, if one of these resistors is open, or anything going on over here on the main board, this is on the main board, then we're going to have the same problem, right? So let's work our way backwards. All right, so we are connected right here at this point, which should be, yeah, that should be right. Okay, we are in offset mode here. And if we adjust the offset, 2 volts, 1 volt, 0, -1, -2, it's working. And the response being inverse makes sense because we have an inverting amplifier there. So, the offset circuit is working properly, which tells us that the issue is most definitely in the output board. So it's going to be a question of where. But yes, it is working fine, as we see right here. So the offset DAC is working. So we can roll that out. The only other thing I can think of is maybe there's a problem in the R2R ladder, or I don't know. We'll figure that out. Alright, so I got to make this super quick or I'm going to fry the transistors because there's no heat sink on it. But if we take a look, we got test point 2. Remember, that was looking good. And then we have, which is over here. And then we have our PAN, which is over there. And the only thing we have in between is this R2R ladder, right? We know the offset looks good. So let's try this really quickly. Let's turn the power on. Let's see. TP2 looks good. Amp in, looks bad. There's a negative offset there. Sucker's getting hot. So, and I tested it right here at R49. And if we look in the schematic, R49 is right here. So somewhere in here, we're getting a negative voltage induced. And I doubt that it's coming from the relays. It's probably coming from this DG211. So that means we need to check our voltage rails here. Because notice we have both positive and negative 12 volt rails. If those are off, we're going to have a weird situation out this way. So let's check 4, 13, and 12 for proper voltages. So where's the DG? There it is. DG211. And we need pin 4, 12, and 13, which is going to be hard to get to because, yes. Well, we can take a look at 12 and 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. These two right here. 12 and 13. So, if we take a look at you, we're going to do that by 5, 10, let's see. All right. 12 and 13. So let's take a look at, okay, 12, 5 volts. Yeah, that's right. So we do have our 5 and 12 volts here. Well, I know our negative 12 volts present, otherwise it wouldn't be pulled to ground like it is. So that's not good. We need to figure out which one of these is pulling us negative. One of these is pulling us negative. Because it looks like there's 4 switches inside the DG211. So I'm thinking if we look at 15 and 10, which is the top side, because the rest of this is on ground. So 10, 15, we can take a look at 10 and 15. 10, 15. So that's on each end here. So, all right, let's take a look at 10 and 15. So 10, nothing. 15. We've got a signal, but there's no offset. All right, so that's not our problem. The only one I can't check is 2 and 7 because I can't get to it. It's like up under here. So I need to chase R39 and R45 and check it from that point. Yes, that's what we need to do. Alright, so it's not in the R2R ladder like I thought it was. I went and probed all of this. What's actually happening right now is we're getting backfeed. Because what I'm trying to do is if let me plug this probe in right here. So here's what I'm going to probe. I'm going to probe right here, which is our input to the amplifier. This is the PA in. There's no test point for it, but we're going to make one. So what I'm going to do, let me get to a wider view here. So what I'm going to do is turn the power on. We're going to go into the offset here, and we're going to turn the offset all the way down. Notice we're bringing it up. See, it's working. It's trying to compensate for the issue in the amplifier. Now, if we probe the amplifier output right here, and we do the same thing, it's slammed over the rail. But what I noticed is if I try to bring the offset up, we start to get some signal in, but that line right there is not moving at all. So the failure is in the amplifier for sure. I noticed though, Q18 gets roasting hot really quickly, but Q19, I think that is, does not. Output transistors, the bottom half the transistors aren't getting hot, but the top ones really are. And if we look at the schematic, the top section here is the upper half of the amplifier because we have resistors here, right? This thing is so negative, we're getting bleed back through here. This is why we're getting a negative voltage here because, like I said, this is part of the feedback circuit. if you were to rearrange this as an op amp, this is the same thing as having the resistors up here and back to the input, the differential input here. Because on an op amp, you have your positive and negative pins. That's what these two are, because this is your diff amp. Anyways, our issue is somewhere in this amplifier, and these guys are getting really hot, which means somewhere in here is pulling it so negative, and these guys are trying to drive it back up. It's dumping so much current through there that they're overheating. So we need to find out why that is. I mean, I could remove Q15 to see if it's a problem in the diff amp. Because if the diff amp is negative, it will drive it negative, right? And it's hard to tell because there's a feedback loop. So if this amplifier is negative, this should be technically being driven more positive to bring it back into equilibrium. So I need to check R69 to see if this is being, if it's trying to drive it positive. If it is, then I know the amplifier, it's trying to bring it back up, which means I need to check R87 to see if R87 is being driven so hard to try to pull it back up that it's causing, yeah, we'll see. I printed this out to try to make it easier. So I have my probe connected to R69 on the diff amp side, which is right there. So that's where I'm connected right now. So let's probe that. Well, it's slightly negative. So according to this transistor should be in cutoff. And if that's the case, then if we move to R87, which is right there, let's move to R87. We're going to move on this side of R87. Now we're going to check U. Let me turn the voltage up here. Because in theory, the way this works, when the signal goes more positive on the diff amp, this conducts, which pulls this further and further away from rail to ground, which will swing the amp that way. So, yeah, we have, it's positive, very positive. So, actually, no, it's not. It's being pulled way to ground. Weird. Let me check you again. Did this thing just settle down? It did. Well, that doesn't seem right. Did my probe come off? No. Hold on, did my probe... Yeah, never mind. It got switched to X10. Okay, yeah, that's very negative. Let's try that again, shall we? Okay, so we're going to take a look at 86 again. I think it's R86, which is right here, right? R86 is on the top. That's what we need to look at. Let me double check. I'm losing my mind. I've been going at this for a few hours now. No, R87. That's what we need to go for. I'm tired of moving the camera back and forth to the computer screen because it's going to make people dizzy. So we just printed it out. All right, R87. Okay, 5, 10, 15, 20, almost, yeah, that's about right. So we're getting full positive rail voltage here, which means this transistor is in cutoff. So that also means this amplifier should be in equilibrium, but it is not. This guy is turned on, pulling it more negative when it's not supposed to be. So why is that the case? All right, we are connected here. All right, well, so that's not turned on. So the problem is not coming from the diff amp. This is more negative, which means it's trying to drive it that way, I think. I don't know. The theory of this can be complicated sometimes. So I'm starting to suspect we have these transistors are turned on. They're trying to pull it back this way, and it can't because something's going on over here. I already pulled these transistors out, which are down here, and tested those statically, and they're fine. So it's gotta be, this has got me thinking. Alright, so here's what I've done. Because of how negative this was, it was trying to drive it the other way. I've noticed a really positive signal right here, which is weird. Because if this is positive, if this signal's positive, it'll turn this transistor on, which will turn these on and pull everything negative, which is what we have. So I said, well, because of how hot this thing is getting, I decided to pull out this one here, which is Q18. So now that Q18 is removed, let's do some checks here. So this is the base. So if we check from base, that looks good. Check there. That looks a little low. So we'll check from collector to emitter. Nah, that's leaky. Well, that'll do it. Yeah, no, that's done. So I don't know what this is testing like, but it definitely ain't a transistor no more. It's testing like a fucked up is what it is. So this transistor is bad. There's our problem right here. Unfortunately, this is a 2N5160. So I decided to look this up on the internet, and these things are impossible to find. You can get them from China, which are going to be fakes. They're not real. There's one supplier that has some of these old stock, and they're like $20 a transistor. It's not cheap, but in order to fix this thing properly, we're going to need to do that. Now, I pulled this one, and I pulled one of these two, and they're fine. It's only this one that's leaky. So, unfortunately, that is our issue. I don't know if there's any other issues in the circuit yet until I get that one replaced. This one tests okay, but because of all the diodes and other things in the circuit, it's really hard to check. It's hard to tell if a transistor is leaky, because most of the time they either go open, or more often they short and they go like 0.000 or something like that. It's rare that they go in a weird leaky way like this. And this one did. So we're going to have to do order and get another one in. But also I got to figure out how to get this heatsink sock thing off of it. Yeah, I'm not sure. But anyways, there we go. So we're going to have to put this project on hold until I can get the new transistors in. Alright, so some time has passed and the new transistor has arrived. Now, these transistors are bloody expensive. Like, I think I was in almost $30 with shipping to get this one transistor to replace the one that is shorted. Because, well, not shorted, but leaky. Because they're not made anymore, and these things are rated for VHF frequencies. So, which makes sense because this is a frequency generator that goes up into the tens of megahertz. So, this is a Class AB push-pull amplifier that's almost identical to something that's an audio power amplifier, right? But they're VHF rated transistors. So, it's funny because when I went to Google this transistor, it said immediately in the title, Wavetek. I'm like, well, that's what this is. So, we have a new one here. I think that is actually a Wavetek part number. But there we go. So hopefully... Now, the problem that I'm going to have with this is... Now, it's been a few weeks, so I've put this thing up and had to unpack it again. But the problem is going to be getting that little part off of that transistor to put onto this one, because this transistor does not have it. So we're going to have to fight with that somehow. Getting out that transistor was more simple than I thought it was going to be. All I had to do was just drive a screw in there, thread it all the way in, and it just pushed the transistor out. Otherwise, there is no getting that transistor out. The more fun part is getting the new one in here, which is Q18. Hopefully the rest of these aren't bad, because the cost of the transistor was more than the cost of the entire thing. And as you can see, it's going to quickly add up if there's more of them that are bad. Yeah, that's how stuck that was. That made a little bit of an impression. All right. New transistors installed. You can see it all soldered in there. Everything's back together. Now, this one didn't have a pad, which is strange, but... Alright, well... There goes nothing. Okay, maybe not. This is a little fiddly. Make sure I didn't kill anything down in here. Nope. Okay, let's get you lined up between here and here. There we go. Ha! It's easier to get in there when you line it up. Anyways, alright, well. Now or never. Does it work or does it not? Nobody knows. So I'm going to take you and ground you elsewhere. And we're going to put you in here. Like so. Switch into a different zoom mode and turn this thing on. Well, we've got something on the screen here, so let's see. Frequency 1 kilohertz. Now the question is amplitude. Well, right now my amplitude is turned all the way up. And we got nothing still. Let's see. Well, we're getting... Yeah, I mean, we kind of got something there, but not quite. If anything, it says we're supposed to have 13 volts peak to peak. That is not... No. Well, we've got different behavior than we had before, but we've still got bad transistors on this board. So I'm going to have to pull out every single one of these transistors and check them one by one, which I was trying to avoid doing because they're so expensive. To replace all those transistors would cost an astronomical amount of money. Might be easier to just get another board, because this is insane. It's maxed out at 15 volts peak to peak, so yeah, that's... But something's happening here anyways. Alright, well, we struck out with that one. Hopefully we get something else. Let me try a different amplitude. Oh, look at that. That's the square wave. Yeah, I don't think that's... No. No, not quite. The important thing is we aren't slammed to rail anymore. Whereas before, remember, we were like way down here, or something like that, I forget. That's not the case anymore. So we've solved one problem, but we still have other damage in the amplifier. Here's another observation. So right now, I've got it in DC offset mode. So if I go negative offset, we're not getting anything over here. That's supposed to be working too, and it's not. But if I keep bringing it lower, we're getting something going on here. So we're getting the bottom half of our waveform now, where we didn't before, but we're missing the top half of the waveform, which not surprised, because if we look at the schematic here, this was the transistor that was damaged, which drives our top half of the waveform. So the bottom half of the circuit is working now, but we still have issues going on in here. So I need to pull out, I might need to pull that back out, check it, make sure it didn't get damaged. Shut the power off. Make sure that one didn't get damaged, and then check the rest of these. Pretty sure I checked most of these, but we could still have a bad one. Actually, I might have jumped ahead of myself here, because I think the chassis ground is at a different potential than the BNC ground. That's my bad for assuming that chassis ground was not. Yeah. Behavior has not changed. We still have that problem. That's unfortunate. It really is, actually. So, yeah. Alright, just to make sure I'm not falling down a red herring rabbit hole here, I decided to pull all the rest of these transistors out, and they're all fine, at least when I use the diode check on the meter anyways. The only one that was giving me a problem was Q18, which I replaced. I pulled the new one back out, checked it, it's not damaged. So just to verify that I'm not doing anything stupid, I pulled out R73 and 74, which is down there at the bottom. R7374 is the V offset input from the digital circuitry. And then the power amplifier input is on R70, which I also removed out of circuit. So the amplifier is effectively isolated away from the circuit. So that means if I put it on test point 4, which test point 4 is our output on the amplifier, and I turn the power on, I still have like negative 13.2 volts there. So the problem is for sure in this amplifier, because we've got some serious offset, and we've also got hard clipping where we're only getting the negative side of the waveform and not the positive side. So where do we go from here? Well, honestly, I don't actually know. The thing about these simple Class A, B type amplifiers is the complexity is in the simplicity. So it's going to be kind of hard to figure out and chase where it is. Now, I've already checked all these diodes. None of them are shorted. None of them are open. The only thing left really is resistors. Other than that, I honestly, I don't know. This might be the one that actually gets me. All right, so the only way we're going to chase a tough dog fault like this is if we isolate every stage away from one another, and that's precisely what we did down in here. So you see all these resistors lifted and some transistors missing. So here's what I've done. I've taken out the 2 driver transistors. I've taken out the pre-driver off the diff amp, okay? I've taken out all 4 of these resistors, which are the base current limiting resistors to the output transistors, and I've taken out these 2 feedback resistors here. So those are those 2 big ones right there. So all of that is isolated out of the circuit, all right? Now, if we turn the power on and I check this output pin right here, we still have negative 15 volts. So we've got leakage currents back on this output section here. So turn that off. There's no path anywhere except for these 4 resistors and these multiple diodes. But those diodes don't go anywhere because everything's out of the circuit. Because these 2 transistors are missing and these resistors are missing. This side, we've got no DC at all, which is good. That means our digital synthesizer is okay. So the problem is in here. We've got some leakage current. So with these base resistors removed, let's take a look here on those base resistors. So we're going to start from the top and work our way down. So if we start at the very top one, we've got negative 14 volts. Next one down, which is going to be R97, negative 14.7. And then we got R98, negative 10.3, weird. And then R99, negative 16.1, weird. So these are the same, but these are way different. So one of these two transistors is leaky, and they statically check perfect out of circuit. But it's possible that a multimeter does not put enough of a load, enough of a voltage drop across these transistors to get them to leak electrically. So I bet one of those two is leaky. Which one? I don't necessarily know. So this is a method on how we troubleshoot a stage like this by isolating them up. So we've got basically everything completely disconnected from this side, leaving only basically that part there, and we still have a problem. We're still negatively tilted on this pin here. So these transistors are not conducting, because if they were, it would drive it back up in that direction. These two, however, are conducting, but which one? I've got a much higher voltage there than I do here, which means I think Q23 is also leaky. So what I'm going to do next is move or remove Q23 and see what we get. All right, so Q23 is removed. Since that was our highest voltage that we measured, I suspect it has the highest amount of leakage currents. So with that transistor removed, we're going to test it again. There you go. 10 millivolts. So our little DC offset voltages are gone. Well, let me check this. Nothing there. Nothing there. So no leakage currents coming out the base. Q23 is also bad, and it's the same one as the one over there. So I got another $20 I need to spend for another one. But we have that one, so I can test it with just the one transistor. As long as I leave this load, unloaded is so I'm not driving a whole bunch of power output. Because if I do, I'll just blow that one up, right? And these things are too expensive to blow up. So, all right, well, I'm going to shove all these parts back in here and we're going to check it again. All right, well, that transistor's out of circuit. Everything else is reinstalled. So the only thing left to do now is to get this thing in my test point and then power it back up here. Ha! How about that? No more negative voltage. So that worked. So there was not just that one bad, this one was too. So there's something I got to say about this. This is the first time in my entire life, ever, and I've worked on a lot of electronic gear, including way before YouTube. I've worked on so much stuff. This is the first time in my entire life have I ever ran into a transistor which statically checks perfect with the diode check out of circuit. I'll grab a multimeter and show you. This transistor checks perfectly fine, including the proper R'(E) across the junction. But yet it leaks 16 volts back to the base when there's 22 volts applied to it. Right? The transistor is leaky, but you can't tell with a multimeter. So it would fool you thinking that it's good, and it is. But if you put this on a curve tracer that goes up to a high voltage, it would not be. All right? Now that I know that one got me. I'm gonna say that one got me. That almost beat me. So I'm just gonna go. We're gonna unplug you. We're just gonna take the oscilloscope here. Plug you in here. Try not to move the camera too much. Make everybody seasick. Grab you. We're going to connect you there. And we're going to turn you on. Oh, yes. Yes. Let's see. I need to... Yeah, buddy. It's working. Nice. Nice. I think my probe is set for times 10, so Output amplitude is set for 5 volts peak to peak. Let's check it to 1 volt peak to peak. Yeah, we're golden. It's working. Wow. Yeah, there you go. It's leaky. It's got leakage currents across the collector to base junction, and it cannot be seen by a multimeter. It has to be under full load to check to see that fault. That's a first one for me. That's going to go in the record books. You'll never believe that. That's that. Yeah. All right. I'm done now. Looks like the supplier I was buying them from is out. Every single one of these are fake. Every one of them. They're not going to be legit. So I'm trying to find actual new old stock transistors, which is proving to be a bit difficult. The one that I ordered was an actual Wavetek part number, and it's gone. There are no more left. So that begs the question, what caused this failure? Well, who knows? Bob's your uncle on that one. Because we had this transistor that was damaged in a weird way. It was leaky. And then this was also damaged, but this one would statically check leaky, and I've seen that a lot. So there's a couple theories I have here. It's possible that, the transistors just went bad and that was the end of it. Or perhaps something was plugged in on this output here, that backfed voltage, because this is DC coupled. So something could have backfed voltage into the power amp stage and killed that transistor. It's possible because you could have, you're working on a radio. I found it at a Hamfest. So someone could have been working on a radio doing an alignment, and some vacuum tube voltage kicked back into the power output stage and damaged the transistor. That's the more likely theory, I think, here. Something backfed and killed that output stage. But who knows, really? It's the only conclusion that I can come to. But it's just so weird with that transistor, the way it failed. All right, so now that I have the meter out, get you in a better position so you can see what's going on. This is the transistor that's bad, okay? So if I meter this out, like, obviously this is what is that? That is let's see, that is a PNP. So if I meter out reverse bias, we get nothing, right? If I go collector to emitter, either direction, we get nothing, like a normal transistor would test. But if we go base to emitter, or one of them, we got 0.710, 0.70, base to collector is 0.702, 0.709. Now, base to emitter is always going to be higher than base to collector. Why? The emitter has a parasitic resistor known as R prime. This is the R prime E value. So what you're reading is the junction, and then the junction plus R prime E. So for all intents and purposes, that transistor is good. It tests perfectly fine. But the reality is, it absolutely does not. And we saw this transistor is bad. As soon as you put 22 volts across the collector junction, you get 16 volts on the base. That transistor is definitely leaky, right? But it's leaky above what a multimeter can apply across it. Now, I don't have one of those little Chinese fancy testers that can read what type of part it is. If it can say, oh well, it's a transistor with a beta of 100 or something. I don't have all of that. But this is how I normally test transistors, and this is the way I've done it for the last 26 years of my life. That is a first for me. That's a first. I'm just gonna give you that. All right, well, some time has passed, and this time I made sure to get more than one transistor because anyways, I know this is the only one that's bad because we did that test, so we'll replace that. I am concerned though that these are not genuine because they have the old Motorola logo, but also they've got like made in Taiwan. I don't know. Anyway, so we're gonna put you in there. Once again, we've got this silly spring clamp thingamabob that's got to get pressed off there because they don't want to come off there easy. So we'll get that taken care of, get that installed, and hopefully this time it'll be fixed. I tell you, even though it's bad, I might save this guy because this one is the one that still tests like a transistor, but does not actually work properly. It leaks back. So I might just hang on to this one. Now, it made an indentation on it when I went to remove it because there's no other way to get it out of this clamp, but that's fine. It doesn't touch the die. Not that it matters, it's bad anyways. Now, I don't remember Motorola parts being made in Korea, for number one. Number two, look how roughed up the case is, how scratched up it looks. But yet, look how perfect that screen printing is. Huh. Yeah, I don't think so. That is probably a fake, but I bought the last genuine one I could get. So I hope this actually works without impacting performance, but we shall see. We shall see. Say that again. it's it's been a long adventure of this dang thing. All right, it's reassembled. A little bit overzealous because I put the amplifier board back together. Clipped onto my test point. Does it work? It does. We have 1 kilohertz. It's dead on. Peak to peak is 10.88 volts. So we've got 2, 4, almost 6 volt per division. What's our amplitude? Yeah, that's about right. 5 volts peak to peak. But we're getting 10.8. I don't know why that is. That might be a bit off. I don't know how this works though, so turn you down. 4. It's about half of what. Ooh, look at that. That's not quite right. But it does need calibrated, so. Yeah, I don't think that's right. So we clearly have other issues going on. At least with the amplitude anyways. Because that is not right. No. But the frequency is working right, so we're up 1 kilohertz. Let's bump you up. Let's see, function. Triangle wave. Yep, that works. Square wave. Yes, that works. Nothing. Yes. Okay, let's see. We have... Oh, well, let's see. We have amplitude modulation. Let's figure out how to do this. Let's see. Amplitude. No, it's already set. Yes. I need to read the manual. There we go. The sweeping is working. Turn the sweeping fast. That's as low as it goes. So it is working. The sweep works. Continuous wave. We got amplitude modulation. But I think in order for the modulation to work, I actually have to do it externally. I need an external source. But, hey, it is working. We just have problems with the amplitude output. 2 volts peak to peak is 4 volts. 1 volt peak to peak is... But then again, I'm measuring from the test point and not that. So we probably need to recalibrate this thing. And it makes sense too, because remember, we have a battery in here that is dead. That holds the calibration memory. So I need to order a battery because I don't have that battery. Yes, but otherwise it was working. The amplifier's working, and that's really the most important thing to me. So let's do a 10-to-1 probe adjustment. Now we're 10-to-1, so that's 20 volts per division. It's as high as it goes. Yeah. 7 volt peak to peak. 7.5 volt, which I'm right now getting about 20 volts. So yeah, it's definitely off. But I gotta look at the manual and figure out how to calibrate this thing. Let's see, reset. Let's reset the whole thing. Calibrate. Wait 15.5 minutes. Okay. We'll just wait. Let me grab you and put you back in the ×1 mode. It's going to be doing something. I don't know. We'll let that run. After waiting 20 minutes and it clicking and flashing a bunch of lights, and I saw a bunch of jumping over there, it says auto-calibrated. So that's good. It means we're calibrated. Alright, what's our amplitude look like? It's still double. 5 volts peak to peak, but I've got 10 on the scope. So 4, 3, 2, 1. That's not right still. It shouldn't do that. I gotta figure out how. Time to start going through the schematics, because that's not right. Now, there's one more thing I can try. Moving that probe back down to here and checking it on the output, because I'm testing it right here at the test point. Now, it's possible when it goes into 1 VPP mode, it bypasses the amps, so I'm getting the full voltage from the amplifier. So let me get a dummy load in here. I got to see if I have one. I think I do. Let's get a dummy load in here. Let's get my probe on that and then check this again, just to make sure it isn't my error in judgment with how I have this set up, because it could very well be. All right, dummy load installed, set for 50 ohms, probe hooked up. I still have it grounded in here, but that's still the same ground. And look what we have. 8 volts peak to peak, 8 volts peak to peak. Imagine that. It was my error in how I had this thing set up for testing. So let me go down again on the amplitude. 3, 2, 1. Yeah, much better. That's all it was. Everything's working fine. I just had, I gotta test it properly. Not testing it at the test point, but down here with the proper dummy load. Now it works, so we're good. It was just me being stupid. But you know what? That's a good thing. I'm glad it was a me problem and not an it problem. But it works fine now. You know, looking at some pictures online, that is not factory. I'm wondering if that's an army tag. This was an ex-military gear, retired gear. Probably retired when the power stage blew up, or maybe it was retired and then someone blew that up by connecting it into a bad load. It's hard to say, but that's where the damage was. So next thing we need to do is we need to flatten out that cover, because it was bented in. It's very thin. So if you stack heavy equipment on top of it, it will dent it. And when it gets dented, it is nearly impossible to get this thing apart. So I need to go grab some blocks of wood and flatten those things out with a hammer before I try to put this thing back together. And there we have it. We're all good. I got this all unbent as best as I could. It slid on easy. Got all my screws back in. But it's fully functional. And all it took was 2 transistors and a whole lot of troubleshooting later to fix it. That's it. Just these 2 transistors. But to find those 2, yeah. I'm just glad that's all it was. There was no proprietary chips or anything that was dead. And I'll worry about the battery later. I mean, as often as I'm going to use this thing, I'd rather just warm it up and recalibrate it and just say heck with it. because I'm only ever going to pull this thing out once in a blue moon to work on a radio IF alignment or something like that. That's it. Otherwise, it's going to sit in a closet until it needs to be used. So, anyways, it's fully functional. That was a repair of a Wavetek 288. So if you enjoyed this video, don't forget to hit the like and subscribe and all that fun stuff. If you have a comment, please feel free to leave one. Until next time, guys, thank you for watching.